We're going to look at one more example where we're given either the roots or the factors, and this one has got some complex factors, so it's a little bit trickier, and I promise you we'll probably see something like this when we do our test on this unit, where you're given a complex root and you have to figure out what the factor would have been in order to get that. So let's walk through this example as a group. So we have some function and it has roots at x equals 2, x equals negative 1/3, and x equals 1 minus I. So let's put like some color around that guy, because when it tells me something like that, there's a big deal. There's some inferences to be made from that root. So let's look at where that might have come from. So x equals 1 minus I must have come from some vertex form. Well, it came from a quadratic, because that's the only way you're going to get an I, is when you square root a number or even root a number. So let's take this and see if we can't put it back into some vertex form. So let's say it was x minus h squared plus k, and then we move our k over and we square root, and then we would get x minus h equals plus or minus the square root of negative k. So that would have given us an imaginary number. So let's see if we can't work this into a form where we can put that square back in so that we can get it back into vertex form. See what we can do with this. So let's move our 1 over to the other side so that now I just have negative I over here. Well, now let's square it. Negative 1 squared is just 1, and I squared is actually negative 1. So I'll move it back over. This is part of f of x. Part of f of x. So I just want to make sure you guys realize something here. So if this were our original function, let's jump right here. When I'm in this form, so x minus 1 squared equals negative 1, and we square root, I'm going to get x minus 1 on this side, and technically I don't just get I, right? I get plus or minus I, which means that this breaks up into two roots. X equals 1 plus I, and x equals 1 minus I. So whenever I see something like this, x equals 1 minus I, part of the reason it's a big deal is because it's a pain. The other reason it's a big deal is because it's telling you to infer that there are two roots, one that's plus and one that's minus. They're a conjugate. We've used this word in the past before, but they're a conjugate pair where one is plus and one is minus. So whenever you see that, don't forget you're looking at two roots. So initially, when you looked at this problem, you might have said that f of x is a cubic because it's got 1, 2, 3 roots, but that's not true because you infer the fourth root here, meaning that it must be a quartic, not a cubic. So here is our quadratic, but of course we're not going to put it in here because that wouldn't be pretty. We would prefer to look at it in more of a standard form. So we're going to actually multiply out that. So x minus 1 squared plus 1 becomes x squared minus 2x plus 1 plus 1 plus 2. So this is our last term. Now you might be saying to yourself, I can see x equals 2 gives us this term right here, but where is 3x plus 1 coming from? Well, it's coming from right here. When we have roots, generally we don't put them in as a factor, so let's look at what that might have been to have given us this. So x equals negative 1 over 3. Let's undo the process that would have got us that root. Let's multiply that denominator out so we're not dealing with fractions anymore. And then I have 3x equals negative 1, and then 3x plus 1 equals 0. Well, then that's our factor, and that's where 3x plus 1 is coming from. So if you have any other questions on that, we can go over them when I see you in class.